Good morning, everyone. My name is Sridhar, and I am from CSAF section. And for complex engineering problem, for and subject is operating system. My topic is about designing of real-time task scheduler for embedded systems. Introduction to real-time task scheduling. Here, the real-time task scheduling is essential for ensuring timely responses in embedded system. It involves managing tasks to meet strict deadlines and also system constraints. Properly scheduling improves system reliability, predictability, and performance. Here, like the real-time tasking schedule, real-time task scheduling is essential for ensuring the timely responses and embedded systems. And also, it involves managing tasks to meet strict deadlines and system constraints. Proper scheduling improves the system's readability, predictability, and also performance. Here, we can see the characteristics of embedded system. The embedded system often operate under resource constraints such as limited CPU, memory, and power. Here we are seeing that embedded systems can offer operate under these conditions such as a CPU like resource constraints such as a limited CPU, memory, and also power. Here we are also having they require deterministic behavior to meet real-time deadlines, and also we can see the task in embedded systems can be periodic and sporadic. Here we are seeing that the tasks in the embedded systems are like might have either periodic and also sporadic. Types of real-time tasks. The periodic task occurs at regular intervals and are predictable. And also, a periodic task happen irregularly and unpredictably. Sporadic tasks are a subset of a periodic tasks with minimum interval arrival inter-arrival types. Here, like there are the three types of real-time tasks. There are periodic tasks, aperiodic task, and a sporadic task. Here we can see that the periodic task occurs at regular intervals and are also predictable. And these periodic tasks happen irregularly and also unpredictable. And also we are having sporadic tasks are the subset of the periodic task, and also which are like which are having a minimum inter-arrival times. And next we see about we are seeing about the scheduling goals in real-time systems, ensuring that all critical tasks meets their deadlines, maximize system utilization without compromising the timing constraint. And also this provides a predictability and responsiveness in tasks. Here we are seeing that the scheduling goals of the real-time system are have definitely having the ensure to all the critical tasks meet the deadlines, and also having a maximize system utilization without compromising the timing and constraint, which are also having the providing a predictable and responsiveness in task execution. And also then we are likely to discuss about the common scheduling algorithm. Here the common scheduling algorithms are like we are having RMS EDF, which are like RMF is rate monotonic scheduling, which RMS, which assigns a higher priority to short periodic tasks, and also earliest deadline first prioritized task with the nearest deadlines. And also we are having the fixed priority scheduling assigns static priority and often based on task importance. Here we are having the three types of scheduling algorithms such as rate monotonic scheduling, which is also known as RMS scheduling, which is assigns the high priority to short periodic tasks. And also we are having EDF, which is also known as earliest deadline first algorithm, which prioritizes the task with the nearest deadlines. And also we are having fixed priority scheduling, which assigns the static priorities often based on task importance. Now we discuss about the scheduling algorithm. They are like rate monotonic scheduling, which is also known as RMS. RMS is a preemptive fixed priority algorithm suitable for periodic tasks, which it guarantees schedulability if the utilization is below a certain threshold. It is simple to implement but less flexible for dynamic task sets. And also, we are having the RMS, also known as the rate monotonic scheduling, which is helps in the like fixed priority algorithm, which is a periodic task, which also helps in guarantees the schedulability and often utilization of a certain threshold. And also, now let's see about the another scheduling algorithm, which is earliest deadline first. EDF, which is EDF dynamically assigns priorities based on upcoming deadlines. It is theoretically optimal for uniprocessor system under certain conditions. Implementation complexity is higher due to the dynamic priority management. Here, the EDF, also known as the earliest deadline first algorithm, scheduling algorithm, which you assigns the priorities to based on the upcoming deadlines. It is theoretically optimal for uniprocessor system under certain condition. Here, we don't know about the upcoming deadlines, so it is practically it is not that good, and also it's theoretically optimal for uniprocessor systems. And also implementation complexity is higher due to dynamic priority management. And also next we see about the another priority assignment and inversion, which are like priority assignment and inversions determines the task importance based on scheduling algorithm. Priority inversion occurs only when lower priority tasks block higher priority ones. And also solutions like priority inheritance help mitigate priority inversion issues. Here we are seeing the things such as like priority assignment and inversion. The priority assignment is determines the task importance based on the scheduling algorithm, and also priority inversion, which describes about the low priority tasks, which are like blocks the high priority ones. The low priority task is blocking the high priority one is also known as the priority inversion, and then where like the solution like priority inheritance helps in this priority inversion issues, and also then we're having some real-time scheduling challenges. The real-time scheduling challenges, like handling task synchronization and resource sharing with deadlocks, managing unpredictable task arrivals and execution times, ensuring system responsiveness under varying workloads. Here we can see some handling the like task synchronization and resource sharing with the deadlines is a major real-time scheduling challenges, and also managing these unpredictable tasks arrival on the execution times. And now we see about uh, design consideration for embedded systems. Here, selecting the appropriate scheduling algorithm based on system needs, and also balancing task deadlines with resource constraint, incorporating mechanism for handling task prioritization and preemption. Here we can see some of the design considerations, such as for selecting the appropriate scheduling algorithm, and also balancing the task and also deadlining with the resources, which also incorporates with the handling task prioritization and preemption. Now let's see about implementation aspects. Real-time schedulers uh, can be implemented as part of RTOS kernel, and careful attention is needed for context switching and interrupt handling. And also the profiling and testing are critical to validate scheduler performance. Here we are implementing that aspects which are having the real-time scheduler, which is which is implemented in the RTOS kernel, and also careful attention is needed for corner switching. Case study RTOS in automotive systems. Automotive embedded systems require strict timing and safety guarantees. Scheduling algorithms like RMS and EDF are commonly used. Effective schedulers design enhances the vehicle safety and system reliability. These are the automotive embedded systems like automotive systems, which anyway safety guarantee, and also RMS and EDF are commonly used to scheduling algorithm. RMS and also we are using the EDF algorithms very commonly. And then coming about the future trends in real-time scheduling, integration of machine learning to adapt scheduling dynamically, use of multi-core processor to improve scheduling efficiency, and also development of energy aware scheduling for power constant systems. Here we can see the diagram where the essential graphic designer process is consists of five parts, which are like collecting the project information and being creative, brainstorming and design ideas, and being creative, and also reviewing those, and also adding the finishing touches. Here we can having some of the future trends, and the conclusion is uh, the proper design of real-time task scheduler is vital for embedded system success. Choosing the right algorithm depends on system constraints and requirements. Ongoing research continues to improve scheduling techniques for complex embedded applications. And also, you can see the conclusion that the proper design of a real-time system task is schedulers is vital for embedded system success, and also choosing the correct algorithm is the most important step. And also then there are like some of the references are like we can see here the Leyland scheduling algorithms and multi-programming, and this is all about and hence this is all about the embedded systems. Thank you.